find the equation of the normal to a curve. That means you're looking for the equation of the line that's perpendicular to the tangent. So what you want to do is at that point, you need to find dy by dx and then find the negative reciprocal of that. So the gradient of the normal is the negative reciprocal of dy by dx at the point that's given. So the point here we're given is x equals 1. So we want to find the negative reciprocal of dy by dx at the point x equals 1. So our first step will be to differentiate this. And even though there isn't a multiplication sign, you can see that this is a product. So we would use the product rule to differentiate. So step 1 is to identify u and v. So that's my u and that's my v. So we'd say u equals x squared. So u dash is simply 2x. And v is 2 minus x cubed. So v dash, sorry, that cubed should be there. So v dash will be 3 times 2 minus x to the power 2. So we take the 3, we multiply, and then we subtract 1 from the power. But because this isn't x, we use the chain rule and multiply by the derivative of 2 minus x. And the derivative of 2 minus x is negative 1. So we multiply by negative 1. That's equivalent of putting a minus sign. So now we use the product rule. So dy by dx is going to be u dash v plus u v dash. So u dash v, that's going to be 2x times 2 minus x cubed plus u v dash. So it's going to be plus x squared times minus 3 times 2 minus x squared. Now, we don't like having a plus and a minus. It's better to multiply the negative times positive, and then it looks much neater like that. And it would be even better if instead of having x squared times 3, it were written as 3x squared. It doesn't matter if you're putting it in your calculator, but it looks neater that way. So that's dy by dx. And what we want is the gradient of the normal. So it's the negative reciprocal of that. So let's find dy by dx at the point where x equals 1. So we simply substitute 1 in every instance of x here. So it's 2 times 1 times 2 minus 1 cubed minus 3 times 1 squared times 2 minus 1 squared. You can put that in your calculator. That's 2, that's 1. So it'll be 2 minus 3, I think, because that's 3 and that's 1. So 2 minus 3, which is negative 1. So now we know dy by dx, we can find the gradient of the normal. And because it's perpendicular, it'll be minus 1 over dy by dx. So it's negative 1 over negative 1. And that's simply 1. So that's the gradient of the normal. Now you want the equation of the normal, which is just the equation of a straight line. And the equation of a straight line can be written as y minus y1 equals m times x minus x1. M is what we just found. It's the gradient of the normal. x1 is given in the question as 1. y1 isn't given, but we can find it because if this is our curve and we know the equation of the curve, we can simply substitute 1 in there to find our value for y. So I can find y1 by substituting 1. So it's 1 squared times 2 minus 1 cubed, which is just 1. So now we know y1, we know m, we know x1. I can write the equation of the normal. So y minus 1 equals 1 times x minus 1. So we don't need to write that 1. The brackets disappear. We can move the 1 to the other side. So we end up with y equals x minus 1 plus 1, because that changes sign. We add 1 to both sides. So we end up with y equals x. And that is the equation of your normal at the point x equals 1.